Hi guys, and welcome back to this journey towards excellent exam results. In these shorter revision videos, we are going to be breaking down different concepts within the GCSE Geography specification. The aim of this is to help us understand the concepts better and to give us the information and confidence we need to answer examination questions. In today's video, we are going to be talking about convection currents and how they cause plate movement and hotspots. This is information that is relevant for all GCSE specifications. Okay, let's get started. So why do the earth's plates move? So the earth's plates move due to convection currents inside the mantle. Now we have already mentioned that the mantle is the molten layer or semi-liquid rock that is just below the lithosphere, which is the crust. And this area obviously has high temperatures, like we had said earlier, and that heat within the mantle and radioactive decay causes convection currents within that molten rock or the magma. And this heat causes, or the convection currents cause the magma to rise up towards the crust. Now, just for the purpose of our knowledge, radioactive decay is the heat that is given off as elements such as uranium within the mantle become unstable and release particles from their nuclei. Okay, so if we look at this diagram here, we can see that as that heat is being transferred through the mantle and through the convection currents, the magma rises up to the surface. So it gets up to the crust here. And when it gets up to the crust, that is when we have step 2. And that is where the magma will spread out along the surface. And as it does that, obviously, some of the magma is stuck to the crust up here and is likely to drag that plate that is at the top, the lithosphere, the crust, is likely to drag it sideways. Now that there is what causes the plate movement. Now because the magma is now near the surface, it's likely to lose temperature. And due to that loss of temperature, it now becomes heavy and dense and begins to sink back towards the asthenosphere. Okay, as you can see here, these are blue arrows representing cooler magma, which now is heavier, it sinks, and then gets back to the asthenosphere and then is warmed again and then brought back to the surface, and that process repeats itself. So over time, the plate that is up here in the lithosphere here is going to be dragged apart very slowly, okay, on both sides here. And that is what leads to plate movement on the crust. And the other thing I'd like to mention here are hotspots. So the parts of the earth where the heat moves to the surface are called plumes, right? So like here, this particular bit here, this is a plume here because magma is coming up towards the surface or towards the crust. And these bring lava obviously to the surface and form volcanoes where the lava breaks through the crust. And if these plumes are in the middle of a tectonic plate, they form what are called hotspots. Now, with hotspots, they are normally in one part of the earth, and that means that as the plate, if they're in the middle of the plate and the plate is moving, it means that the plate will keep moving over that particular plume, and over time, because the plate is moving, you will have a series of islands that are likely to be formed by the magma that has reached the surface. An example of that happening is Hawaii, where you have a series of islands on that particular plate. That brings us to the end of this video on why tectonic plates move. I hope that you have found the information insightful and useful. I have also done a video on the types of tectonic plate boundaries. It will be linked in the description below and will also pop up as a suggested video at the end of this one. Thanks once again for joining in this journey towards excellent exam results. All the best and see you again soon. Bye-bye.